So you still, yeah, so again, that first one we did, 3 by 3 by 3 cube, dipped in paint, pull it out, let it dry, pull apart all 27 individual cubes. We walked through that process of how would we do 20, like for a 3 by 3 by 3. Procedurally, think through it the same way. Math is the study of patterns. What patterns start to emerge? Because you're going to probably guess where we're going after you figure this one out. All right, so in class here we did this one. We looked at the patterns. We determined, there we go. We determined how many sides of each, and I didn't write it down on this. How many were 0 sides? We said there was 1. How many were 1 side? We said there were 6. How many were 2 sides? 12. And then 3 sides was 8. And then from there, then we did this one, and we said, oh yeah, 3 sides will have 8. 2 sides we said was 24. 1 side we said was no. So 0 sides we said here was 8. I can't remember what we said 1 sides was.
I thought 1 was 24.
1's was 24?
Yeah.
Do I have 2's wrong then?
Yeah, 2's was 36.
2's was 36.
I'm right. That's not that. What was it, guys? For which one?
How many had 2 sides?
4 by 4. Oh, for the 4 by 4?
Yeah.
That was 24, right? 2's had 24 as well.
Was it also? I can't remember.
Yeah.
All right, 24. But again, when in doubt, this had to add up to 64 because there are 64 cubes. And then again, so if you're watching on video, you didn't get to be part of the process if we're actually like discerned all this. And then we came up with a formula for the n by n by n. So if you're watching online, you're going to have to work on that your own. But now we're going to kind of jump back and we're going to talk about another algorithm. So algorithm is a fancy word for process and procedure. So the algorithm of long division, hopefully I'll do this and you'll go, oh, yeah, I remember this. And some of you are going to go, oh, if we could just go back and only do this, this would be great because this I get and understand. But I'll tell you what, the first time you had to learn this, you did not understand what was going on. So if we divided 1, 2, 3, 4, 5 by 15, we did this. All right. Now make sure you only do a division sign. Don't put the little hook on there like it's a square root symbol. Some of you get in the habit of doing that now because you're a little bit more advanced mathematically and you put the little hook on there accidentally. It's just the division symbol. But when you did dividing, we said how many times does 15 go into 12? And the answer is none, so we put a 0. And then we say how many times does 15 go into 123? Well, 15, 30, that's 2. 4 30s is 60. 6 15s is 90. So if we did 8, so 8 times 5 is 40. Move the 4 up here. 8 times 1 is 8. All right, 8 times 1 is 8 plus the 4. 12. Yay. And then we subtract. We get 3. Then you bring down the next one. And we say 15 into 34. Well, that's 2 because we know that's 30. Subtract. That's 4. Bring down the 5. 15 into 45 is 3. That's 45. Subtracts to 0. That's my final answer. All right. And then what happens if we do 1, 2, 3, 4, 5 divided by 16? We do the same kind of process, get going here. So this, if we try, I don't know, I'm going to try 7. That's 42. 7, 8, 9, 10, 11. All right, that works. This is 1, and that's 1. 11 is less than 16. So that meant I chose the best number. If I would have done 6 and got a number larger than 16, then I got to go back and change that to a 7. Bring down the 4. 16 into that. Maybe 6 times. Oh, same number. Yeah, I'll just use the same number because it's 112. So that's 25. 16 into 25 is 1. 16, 15 minus 6 is 9. So I have this and a remainder of 9. Remember doing that way back in the day? You're like 9, remainder of 9. But really what I would do, my answer would be 771 and 9/16. Because it was 9 out of 16. And then later on, we did this as an improper fraction, 1, 2, 3, 4, 5 over 16. That would be an improper fraction, and then we made that into a mixed number, which is that. And again, this is something that you go back and like, okay, yes, I've done this. I got it. How are you going to ruin this for me there, Mr. Steffen? Here's how. Yep. So here's what we're going to do. We're going to do long division using polynomials. So watch what happens. Try not to write this down right now. I'll give you a second to write down a couple notes to yourself in a minute. But I want you to watch the process, listen to the procedure. And if anything, you're writing down procedural things or questions that you have as we do it. But I'm going to start with, and I have to write it what's called in descending order. So the highest variable is 10x cubed. Then I'm going to subtract 5x squared, then 20x. And then, is there a number without an x? No, so I'm going to say plus 0. And I'm going to divide it by x minus 5. When I do this, again, like we did in long division, I'm only going to look at the first thing. I want to say x to 10x cubed. How many x's go into 10x cubed? There are 10. And look, I'm going to write it above the next number over. All right? And then I also need an x squared. So again, what we're thinking of is x times what gives me 10x cubed?
Oh, okay.
Or you're thinking 10x cubed divided by x, and that's that number. Either way, I'm looking for this number. So then this number is going to multiply by x to be 10x cubed. And then this number is going to multiply by negative 5 to be negative 50x squared. Again, because 10x squared times negative 5 is negative 50x squared. And then I'm going to subtract. I'm going to make it a giant subtraction line out here because the biggest mistakes that's going to happen is you're going to do your subtraction wrong. I have to remember that minus to this and then minus to that. So first thing first, 10x cubed minus 10x cubed is 0, and it should be. That's what I want it to be. If it's not 0, I did something wrong up here. So this is 0. Negative 5x squared minus a negative is plus. So I have negative 5 plus 50. 45x squared. And then I bring down the next term. And I do the same process again. X times what number is 45x squared, and that's going to go above the x term. All right, so this is a 1, that's a 45, so I know that my number up here has to be plus 45. I have x needs to become an x squared, so that 45 also needs an x. Which again, if I'm doing my process right, makes sense because it's above the x column. This was above the x squared column. And we're going down each time. So then I take this 45x times x gives me 45x squared. I do 45x times negative 5. And here's where sometimes, like if you're not super fast on the multiplication, you got your calculator out so you can do it. And I don't have a calculator, so I'm waiting for someone here in class who's got their calculator out to do 45 times negative 5 and tell me what it is. Negative 225, and there's an x because it was 45x times negative 5. Okay. Then I'm going to subtract and bring down and say, okay, this adds to 0. 45x squared minus 45x squared is 0. Again, if I'm doing it right, that will always be true. 20 minus a negative is plus a positive. 20 plus 225, 245x plus 0. Now I need this to be 245x. Well, it's already x, so that number needs to be 245. I go 245 times x, that's 245x. 245 times negative 5, I know it's going to be negative. 1,000. 1,225. Subtract. 245x minus 245x is 0. 0 minus a negative is plus a positive, so it'll be positive 1225. And that's my remainder, which gets written as, it's positive, so it's going to be plus 1225 over x minus 5. That was my remainder, just like I did before, where my remainder was something out of 15. I think it was 9 out of 15, or 9 out of 16, it was 9 out of 16. So the remainder is in the numerator. What it was out of is in the denominator, and I was adding it, just like, well, on the last slide I didn't write add because there were numbers, but here I have to write add. So if I had to do all of this long division, this would be the solution for long division. We'll do this one, which should be a little bit simpler in terms of we've done it like this a different way, but we're going to do it by long division. So I'll start it by writing it down in descending order. I don't like blue. 10x cubed minus 5x squared plus 20x plus 0, because there's not a number there term. And then I'm going to do 5x into them. 5x into 10x cubed is 2x squared. All right, because I was thinking 5 gets me to 10 by how? By multiplying by 2. X gets me to x cubed how? Multiplying by x squared. That will be 10x cubed. I'm going to subtract, that's 0. Bring down the next one, negative 5x squared. 5x, how do I get to negative 5? Well, that'll be negative 5. How do I go from x to x squared? That's times x. And again, that makes sense because I'm in the x column. This was in the x squared column. There's a pattern and a rhythm to this, all right? So then I multiply, and that's negative. Oop, I don't need 5. This up here needs to be a 1. I started to multiply, I get 25. I'm like, oop, I did something wrong. That's a 1. Now I'll have negative 5x squared, subtracting, minus a negative is plus a positive. Negative 5x plus 5x squared. Negative 5x squared plus 5x squared is 0. Bring down 20x. I need this to be 4, which will be 20x. Subtract, I get 0. Bring down a 0. I need it to be 0. What do I multiply 5x by to get 0? 0. So then it would be plus 0, which we're not going to write because, well, actually it's 0, so that's my remainder. My remainder is 0. All right. So the way we did it in the past is we just did each of them over, so 10x cubed minus 5x squared plus 20x over 5x. I can split this up into individual fractions, 10x cubed, so I'm kind of like unsimplifying, if you will, right now. All right, so split them up as 3 separate fractions because they all have the same denominator, and then reduced. procedurally do another one of these, and then I'm going to show you a shortcut. X squared minus x minus 10. That is already in descending order, so I'm going to divide by x plus 2. So then I get here, this is going to be 2x, which will give me 2x squared, and then plus 4x. I'm going to be subtracting negative x minus 4x is negative 5x. Bring down the negative 10. This will be negative 5. Again, as you're watching along, you're hopefully trying to predict what number should go in there because I'm paying attention to what's happening. Because negative 5 times x is negative 5x. So it'll be negative 5x. Negative 5 times 2 is negative 10. I'm going to subtract minus a negative is plus a positive, that's 0. Minus a negative is plus a positive, so 10 plus 10 is 0. So my answer would be 2x minus 5. There is no remainder. So the next step is what's called synthetic division. This would be what, if you can figure this out, becomes a significant shortcut in the process. I write it in descending order, but I only write the coefficients. So my first coefficient there is 4. The next one is negative 25. The next one is positive 35. The next one is 0. Wait, what? 6, 5, 4. There isn't a 3 power. So that's 0. The 2 power is 17. The 1 power is nothing. So there is no just x term, and there's also no constant term. This would be a really, really, really long process. All right. The one thing I like about synthetic division, 1, it takes up less room. 2, it uses addition instead of subtraction. And I like to add. When I subtract, I make mistakes. Then what we do is we do this and this, and that's just a way to keep track of things. But what I'm looking at is I look at this. I don't put x minus 4. The difference here is now this would be considered a factor. The number in here that makes this thing 0 is called a root. So I'm going to look at this and say, what makes this 0? 4. 4 minus 4 is 0, so 4 goes here. So I go and I put 4. And I start by doing this. I bring this down and I say 4. I take 4 times 4 and I put it right here, and that's 16. And then I add. Negative 25 plus 16, which I think is 9. Am I right? Negative 9, because it's a negative 25. All right? Then I do the same thing. 4 times negative 9 is negative 36. I add those two up, and that's negative 1. I do 4 times negative 1. I put that right here. That's negative 4. And then I add. That's also negative 4. Negative 4 plus 0 is negative 4. I do negative 4 times negative 4. That's 4 times negative 4 is, yep, negative 16. Add. That's 1. 4 times 1 is 4. Add, it's 4. 4. Hold on a second. There you go. 4 times 4 goes here. That's 16. And then add, I get 16. So here's what it means then. I started with x to the 6th, so my first term will be 4x to the 5th. How do I know that? Well, this was 6th. That's just to the 1 power. So it's going to be 1 less power when I divide. Negative 9x to the 4th. Minus x to the 3rd. minus 4x squared plus x plus 4 plus 16 over x minus 4. That was my remainder. That is synthetic division. Going to do another one so you can see and watch that process. We'll try using synthetic division again. And we look at this and we start by saying, okay, I got to write this in descending order with coefficients. So my highest power is 4, and the coefficient on that 4, on the x to the 4th, is 1. Is there an x cubed? No. So its coefficient is 0. Is there an x squared? Yes. Its coefficient is negative 26. Is there an x? No. Its coefficient is 0. Is there a constant number? Yes, its number is 25. I'm going to put my little box over there and do this. So again, step 1, I write the coefficients in descending order, making sure that I don't miss any of them. Then I look at what I'm dividing by, and the instinct is to put -1, and that would be the wrong instinct. What instead I'm thinking is, what makes this 0? 1, yep. Because if x minus 1 is a factor, that means 1 is a root, sometimes called a 0. What? Because you're asking what makes it 0. 1 minus 1 is 0, so 1 is a 0. It's also called a root. That goes here. So when you look at your book, it says you put the root right there. Unless you remember what a root is. A root is a 0. Well, what's a 0? A 0 is something that makes the factor 0. Procedurally, bring down the first item, then multiply. 1 times 1 is 1. And then here in this whole process, we're adding. 0 plus 1 is 1. And then I take 1 times 1 again, and I get 1 again. And that will be negative 25. Negative 26 plus 1. Then multiply. Negative 25. 0 plus negative 25 is negative 25. 1 times negative 25 is negative 25. Add them up, I get 0. So what this means is x minus 1 is considered a factor of that whole equation. Remember when we did factoring of trinomials? We had our a times c process and all these other things. When we have polynomials, which are bigger than x squared, we have to use division to find out, is x minus 1 a factor? When the remainder is 0, the answer is yes. Yes, it is. And it would be x cubed plus x to the second minus 25x minus 25. And if I would take that and multiply it by x minus 1 with a massive, kind of like the FOIL method, a massive distributive property, x times this, x times this, x times this, x times this, -1 times this, -1 times that, -1 times here, -1 times that. Simplified it all up, it would give me my original equation. So when we did factoring before, using the processes or looking to see if there's a difference of squares, now for polynomials, is 1 a 0? Another way of asking that is x minus 1 a factor? Well, we do long division or synthetic division. If the remainder is 0, then the answer is yes, it's a factor. It's a factor because when I divide this out, there's no remainder. And that's what it means to be a complete factor. The previous answer was x cubed minus 25x squared minus 25x minus. So I'll leave these two up to you. So when it says divide the previous answer by x to the 5th, so the 25, so that's x cubed plus x squared minus 25x minus 25. Divide it by x plus 5. So you'd set it up and say 1, this is an x. So that's a 1, negative 25, and negative 25. Over here, my number is -5 because that's what makes this 0. Finish this out. If you do it, the remainder will be 0. Take this answer then and divide it by x minus 1, or x plus 1, which means when I do this down here, I'll use the coefficients, and I'll use -1 into it. It should also be 0. So what you're going to find is as long as, I think it's 0. I can't remember now off the top of my head. But that would be something that I would want you to give a try on your own. That'll help you walk through the problems that you're supposed to be doing for today. All right, and then after that, this gets us to then 6.4, a much bigger fraction. These look ugly, but don't worry, they're not that bad. Dividing by a fraction is the same as multiplying by the reciprocal. I'm only multiplying and dividing, so I can actually just rewrite this as 2 times 9 times x, it's a 9, not a q, over 7 times y squared times 6 times x squared. And then I can do reducing. 2 divides into 6 3 times. X divide, that looks like a 2 then, doesn't it? It's hard to cross out an x. Have you ever realized that? Because it looks like, an x. So x divides with one of these x's, leaving just x. I have no y value, so this would reduce to 9 in the numerator. 7 times 3 down here is 21 x y squared. So that would be simplifying that ugly looking fraction. Same idea, but now we have uglier looking fractions. But I start with saying, okay, dividing by a fraction is the same as multiplying by the reciprocal. So I rewrite 5x over x plus 2 times x minus 2 over 10. So then I would have 5x times x minus 2 over 10 times x plus 2. Then I want you to think, but don't answer out loud. But in your head, you're saying, oh, I think I can start reducing. The answer is correct, you can. But if you start to reduce that x, you're doing something mathematically horrendous. Because the x is trapped inside the parentheses. The only way that x reduces is if I have identical and x minus 2 in the denominator. Do I have x minus 2? No, I do not. These cannot be reduced. The 2's can't, the x's can't, they stay as is. This x cannot reduce with that x because this x down here is trapped again with addition. We reduce when we're only multiplying. I have 5 times x times this parenthesis set. Down here I have 10 times this parenthesis set. If the parenthesis sets are identical, then yes, reduce. If not, then no. But the 5 and the 5 can, or the 5 does with the 10, leaving me with x times x minus 2 over 2 times x plus 2. And that would be the final simplified version of that expression. Because, of course, we don't end there. So we're going to start by saying x over y squared plus 1 over y. Before I do the multiplying and the fractions, I'm going to simplify this. I need them in order to add them to have the same denominator. So I need to multiply this, we did this the other day, by y over y. Y over y is 1. So multiplying that by 1, just that one thing. You multiply by 1, it still is the same value, it just looks different. So then I'll have x over y squared plus y over y squared. Now I have same denominators, now I can add. X plus y over y squared. All right, well that's my numerator. I'm going to take this thing down here, y over x squared plus 1 over x. All right, different denominators, need to have same denominators. going to multiply this by 1. It's a fancy looking one. X over x. So then I would have y over x squared plus x over x squared. Because again, it's just x times 1. Just like up here is y times 1. That's how I got the y. X times 1 is x. X times x is x squared. X over x squared. Now I have same denominators. Now I can add. Equals y plus x over x squared. Now I'm going to take that top thing, which is this, and write it as x plus y. X plus y over y squared. We're going to multiply it by the reciprocal. Well, this was the denominator, which ends up being this. So I'm going to multiply it by this, but flipped. X squared over y plus x. Then when I multiply, I'll have x squared times x plus y. I'm not going to do distributive property. In the bottom, I'll have y squared times y plus x. Do I have anything in the numerator that is identical to something in the denominator? Think. Don't say it out loud, but you're looking at it. Is there something in the numerator that is identical to something in the denominator that's being multiplied? I got x squareds up here. Do I have any x squareds or x's in the denominator that are being multiplied? Shake your head and say no. No. There's an x, but it's being added. Oh, can't do anything with that. Is there a y? There's a y squared in the denominator. Are there any y's or y squareds in the numerator that are being multiplied? Nope. But I have an x plus y. Is that the same as y plus x? Is 2 plus 3 the same as 3 plus 2? Is 9 plus negative 1 the same as negative 1 plus 9? Yes and yes. These are the same thing. So I could rewrite this one, and I will, as x plus y. X plus y, y plus x, that's the same. That whole parenthesis set is identical. That reduces, leaving me with x squared over y squared. Let me see what my next couple slides are. Actually, so I would like you now to give this a try using synthetic division or long division, your choice. But just going to pay attention here quick. I have a fourth, a third, a second. We're missing an x, and then a 34. So whether you use long division or synthetic division, I want you to give this a try right now, and we'll do a solution before we go. Assuming if I did all my positives and negatives correctly, that would be the final solution there. To do long division,
You get to the negative 18, so wouldn't that be negative 12?